Okay, so good afternoon again. They will be the final chapter of this subject before you have a midterm, and then after midterm, you will learn with another instructor. Okay. Uh, okay, so as I told you earlier, so this today. Today is 6 October, right? So this is last chapter. And then because the next week is a national holiday and the building is closed, so we cannot enter the building. So we have to skip 1 week. Then you have more time to read the book, to train yourself, and then we back to meet again. At 20 October, we will have the exam. Okay, so exam will be 30 points. Oh, the color is so bad. Let me change the background. Okay. Uh, okay. So the exam will be 30 points with this open book exam. So I ask you for your preference. You have two choices. First, to test in this computer room or test at 14 floor using paper base. Which one you prefer? Do you want to use computer to type or do you want paper to write? Computer. Okay, we will have a test at computer room. It means you can search on the internet. That's okay. But yes, the exam will similar to the homework and also what we have learned. So the one that we didn't learn, I will not exam you. Uh-huh. So yes, homework and also the class assignment in the class. For example, to compute something or uh, to interpret the printout like the style of uh, interpreting the printout should be similar to what I teach you. For example, you have to say pop f is less or equal 0.05 indicate that and then R square and then t. Okay, if you will get full marks if you follow my instruction because some of your seniors they because they allow to use internet as well. So some people just look from the internet and try to copy from the internet, and it's not good way to answer my exam. Okay, if you would like to get the point, use my style of interpretation because it means you understand my lesson. But of course, something that you cannot remember or still in the gray area, don't understand it clearly, you can search from the internet. You can see the handout, or even you go to the my my YouTube video and watch along in the exam room. But I'm not recommend because it takes too much time to find the exact time to answer, right? Okay, so prepare it in advance should be better. Okay, so of course, the exam will insist of interpretation. Of course, this is I would like you to do it and understand it. Okay, interpretation of the printout. Okay, so this is the significant and to this one 100% will be the exam. And then we may let you to calculate something, right? Like I may give you some printout and hide some value. For example, t r square. Then please find the value. This means you have to know how to calculate any number in the printout. If I hide r square, you can compute r square. If I hide t stat, you can compute t stat for me. Okay. And of course, since we have done a lot of hypothesis testing, I will test you about hypothesis testing as well. Okay, so interpretation means you have to follow my instruction by you interpret F first, right? Then followed by R square, and then each beta using T stat to see whether it's significant or not significant. Moreover, when you interpret individual T, it depends on the model style, like linear. You have the way of interpretation, log. You have another way to make the interpretation. How about linear log and how about log linear? So you have to know how to interpret all of them. The color is so bad, right? Oh, it's okay, okay. Okay, good. Better? Yes. Uh, and then since today is the final class and you all did well, okay, so you have class attendance 10 points already. Uh-huh. And then you have assignment since you submit on time every single week, so you got 10 points. So together you have 20 points in your hand now. So another 30 points is in the exam. Okay, and this will be my part, 50 points. Then you will learn with another instructor. Okay, so let's see the homework solution first, and then we will start a new chapter. Okay, so last time I gave you computer homework, right? So did you try that? We did it together in the classroom as well, right? So this one is not difficult. By estimate this one, you will get either this way or this way. Okay, this means you let's tweak to be the constant of return to scale. Okay, it means you try to fix that beta 2 plus beta 3 equal 1. So you type uh, the full equation like this, then you get the result. And then they would like you to comment on the results. You may comment it quickly first. Of f is okay. R square is quite high, but its probability is so bad, right? Is greater than 0.1. It means it impact is not significant, not so good. Mhm. Not so good. So there must be some problem with this model, but you will learn it in the second part of this subject, how to deal with this result. So you just comment that, okay, this is not so good, but how to fix that later, you will learn with another instructor at the second part. Okay, so this what you can do for homework 5.1. For 5.2, so they would like you to estimate the model and report the result and comment on the size and significance. Okay, so this is similar to the exam. In the exam, I may give you several printouts, so you have to understand what happened to the model. So first, they would like you to comment on printout A. Okay, so you must say, okay, since log F is less than 0.05. Okay, if you write in the exam, you may write in full, right? The models can something, right? This model can explain dependent variable. Okay, but when you work in the real situation, you may say, okay, of f less than 0.05. Okay, right? Next, r square find 8. So 68%, the model can explain the real data, right? Or the real data 68% of the data fit the model, right? And then we will comment on individual T, okay? So T, this is 1, 2, 3, 4, 5. So beta had to equal 0.03 with is pop as 0.01. Indicate that. So T is 20 term. So each time change 1 year, right? If time change by 1 year, y which means yield increase 0.0 t in the unit of tons per hectare, tons per hectare. Okay, and if you would like to get the full mark, you have to say that it significant at 1% level. Other X L constant. Yes, L constant. If you write in full, of course, I will give you a point. Then other beta 3. So this is about the rain. So rain G, May to June, rain D, July to August, and then September to October. Okay, so this is all about the rain. So beta 3 minus something with probability is, yes, it's more than 0.1. So bad, right? So it means if the rain increase one rainfall, then no unit, rainfall, rainfall. They don't give us the unit of rainfall. Okay, so rainfall increase 1 unit, but yield decrease. So it's very weird, right? Yield decrease 0.01, but insignificant, right? Insignificantly. Alternatively, alternatively, you can say that rain has no effect on you, which is doesn't make sense because if you do something agriculture, so it depends a lot on the rainfall, and then the model said that the rainfall has no effect on you, so you feel like, oh, it's not the good reason to explain. Okay, so as well as beta 4 similar because it's minus something as well. The pop is less over 0.1 as well. It means you can say it's increase, you decrease not significant, or you can say that RD has no effect you. Yes. Okay, either way is okay. You can say that it's effect but not significant, but insignificantly. That's okay. Or it has no effect, is not affect you. Either way is okay. However, RF is good enough because RF beta 5 has equal 0.33, right? With probability is not 0.01, 0.05, 0.05, which means if the rain is fall, yes, the yield increase, yes, ton per hectare, which is significant, not one at 5% level. Okay, other X L constant. No space, right? No space. But the keyword is here, right? Significant at 5% level. Okay, and this one is makes sense because if the rain is higher or the rain is rising, the rain is rising the level of water, right? So the level of water is rising, the yield is better. Yes, this one is makes sense, but not the first two because it's not significant. And then they would like you to test the hypothesis that the response of yield to rainfall is the same irrespective of whether the rain falls during this month. Okay, so test B, they would like to test whether beta 3 equal beta 4 equal beta 5 or not. Okay, so in the program, you have to click on the wall test. Do you still remember? Click on the wall test and set beta 3 equal beta 4 equal beta 5. And then after you get the result, you can come to the probability. Okay, if it's greater than 0.05, you go to S naught. If it's not, you go to S1. So this case is This case is which case? S now or H1? 0.007 H now or H1? 0.07, 0.07, 0. Slowly. 0.07 is greater than 0.05 or less than 0.05. Is more than, yes, it's more than 0.05. You have to conclude HO, which means C3 equals C4 equals C5. What does this mean? It means uh, the response of you to rainfall is the same. Yes, same. Whether RG, RD, or RF, they are all the same effect on Y. Whether the rain fall in which month, May, June, July, August, or September, October, they affect you similarly. That's why they would like to test whether all the beta are the same or not. And then the answer is yes, it's the same. Beta T equal beta 4 equal beta 5. Understand? Difficult. This is when you work with real data, you have to click on the printout and then you have to know how to read it. Okay, so this one, they claim that all the beta are the same. Since all the beta are the same, you can change the equation to be 3, oh sorry, beta 2, 3 plus, so beta 3 equal beta 4 equal beta 5, right? So beta 3 RG plus, since beta 4 equal beta 3, I will write beta 3 again. RG plus beta 5 equal beta 3, so I write beta 3 again. F. And then since beta 3 are all the same, I can group the variable to be beta 3 RG plus RD plus RF, right? That's why in the party, estimate the model under the restriction that three responses to rainfall are the same. Comment on the results. Okay, so in the e-view, you have to type RG plus RD plus RF in the right hand side here. Did you try it? The homework? If not, we will do it together. So after they try R3, RD plus RG plus RF, okay, so the direction. Okay, first, if you read this print out, what do you read first? Oh, what do you read first in this print out? After you get this print out of, of F, yes, of F, pass or not? This is good or bad? Good, right? Because it's less than, yes, overall is okay. And then R square, which means yes, yes, 64% is data fit the model, so it's quite high. But uh, for individual team, this what that is mean? Yes, you have to see the probability. Is it good or bad or no idea? Is it good or not? 0.8. More than. What does it mean? More than 0.1. What does it mean? What does it mean? What does it mean? Oh. No, you have to be careful because this one will be test 100% to read the probability. Uh-huh. Okay, I quickly review again. Quickly review again. Okay, first when you read the when you get the pin out, right? Then you read the probability, right? So first you leave pop F. Okay, pop F you have only two cases, whether it's greater than 0.05 or less than 0.05. Okay, if it's less than 0.05, it means overall the model is okay. Okay, if it's not, you can throw away. So bad, right? So this means okay, but this is my ranked. When you write in the report, you have to say overall the models can explain why something like that, right? Using the technical term, but the the meaning behind is mean it's okay. The model is okay. Then you go to read R square, right? R square no problem for you because all of you can uh, answer this. So R square can answer that many percent of data fit the model. So it means how well of your model to use for forecast. And then you have to interpret individuality or oh my, what happened? Can I back to the same position? Okay, okay. And then they have the probability here, which is the number three. So you have to interpret T. Okay, so T individual, you have to know whether it's greater than 0.1 or not. Okay, if it's greater than 0.1, you have to say that it's insignificant or not significant or has no effect or not affect. Okay, you use some bunch of words like that. But if it's less than 0.1, you may divide into three cases, 0.1, 0.5, and 0.01. So all of them you call it significant. But they significant at the different level, right? This one is significant just 10%. This one is 5%. And last is 1%. Okay, clear? Okay, so the keyword here it depends on the probability. Okay, if it's greater, you say it's not significant. Okay, yes, yes. Okay, so you may remember this picture because this is the way when you have to interpret the result. Mhm. Moreover, when you say not only the probability, right? When you interpret individuality, so you have to interpret linear, log, log, linear. So linear, you x increase in 1 unit, y increase beta unit, log x increase 1%, y increase beta percent. Linear log x increase 1%, y increase because it's linear, so you have to beta over 100 unit. And lastly, linear x increase 1 unit, y increase beta multiplied by 100%. Okay, you may make this one as the sheet my cheat sheet. So if you press please interpret the result, you may come to look at this and then okay, pop F greater 0.05 go away. No, don't use this word in the exam. Okay, this is my verbal language. That's totally no, you can. Okay. If you do the exam or report, you may use some, okay, say some formal word, more formal word, like the model overall cannot explain why, something like that. But the reason behind is the meaning behind this whether model is pass or not pass. Okay, so if prompt f less than 0.05, it means overall model is okay. If not, you stop to interpret everything. It means the model you have to go away. Okay. Okay, remember this picture and answer me again. Answer me again. First, top F, okay? Okay, because it's less than 0.05. R square, no doubt. Okay, T, this one is good or not? 0.000. Good. Yes, it means less than which one? 1%, 5%, 10%. 1%. Yes, correct. Correct. So 0.0000 it means it's significant at 1% level. How about 0.8? Uh-huh. Insignificant. Yes, of course. It means the real meaning is mean the rainfall because RG plus RD plus RF is the rainfall. The level of rainfall has no effect on yield because why is yield? So the result suspect that indicate that the rainfall does not affect you. This is weird or is make sense? Make sense? Are you sure? Rainfall. Rainfall. The rain. You know the rain? The rain. Do you know the rain? Rain. When rain, yes, rain. This one, rain. Water from the cloud. Rain. This one, the rain. Huh? Ah, this one, the rain. And this is water, right? And then the yield is mean your agriculture yield. When you plant something, when you plant something, so this is the wheat yield. Uh-huh. So when you grow the plant, you tree, for example, you need water, right? Uh-huh. Okay, you need water, right? And then, and then they would like to test how about the level of water affect the yield or not. But the result that show that it does not affect. So it doesn't make sense. You have to say that, oh, it doesn't make sense. It should be affect you. Okay. So let's back to the print out A first. Print out A, they even say that it have a negative effect. The more water, the lesser yield you get. Even weird, right? Uh-huh. So at least this one is may not significant, but at least the direction is correct. It still have a positive effect, but not significant. Okay. Okay. So next over, reconsider the production function. Then estimate this one and test the hypothesis. Okay. This is print out a please answer. What should you read first? Ah, yes, you get the print out A already to perform your data. What should you do first? Probability. And yeah, this is okay. Okay. Yes, good. Next one. R square. Yes. What does mean? Good. Okay. How about log area? Log. This log model. What should you interpret this model? Okay. One, two, three, four. So beta two hat two. Which probability is Sorry. It's zero, 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 zero. Zero point zero one, 0.05, 0.1. And this is zero, 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 zero. It must be around here. So it must less than. Yes, significant at 1% level. But how can we read this better? 0.36, what does it mean? What does it mean? Yeah. No, not log area. Is if the area, not 1 unit. One what? One what? Yeah, we just write together. Where is it going? Where is my note? Percent, yes. Thank you. 1%. Then the production. T6 what? No. T6. Point T6 unit percent. This is 1%. How about put? No. The note is gone. The note. My note, where is it? Yes. No. Lock. Yes. Lock. Yes. Yes, this is elasticity. Okay. Make 100 star and practice is wisely to interpret four type of model because I will test you 100%. Okay. You have to answer it correctly if you want to pass the test. Okay. So area increase 1%, production increase 0.36%. Then and is significant at 1% level. Yes, after X, yes, good. Moreover, beta we had. How about it? Yes. Yes. What does it mean? Percent. Good. Production. Yes. Yeah. Good. One more time. Mm-hmm. Mm-hmm. For fertilizer first. Mm-hmm. Mm-hmm. Yes. Of course, correctly. Yes, you have to practice a lot because this is the the main thing that you will remember and use it. Because a lot of my students they maybe learn a lot of technique in the future, especially in the second part, they have more technique on the model. But this is like the basic to read the printout when you get the data and then create the result. So you have to know how to read probability, how to read it R squared, how to read of F. It is very important because when you go to more advanced topic, this is will be the fundamental to do other topic. And if you know it, you understand it, other topic will not difficult. Uh-huh. Just to know how to read probability. And then they would like to test the hypothesis that production function exhibit constant return to scale. They would like to know whether beta 3 plus beta 2 plus beta 4 equal 1 or not. How do you know? Okay, so if you do the computer exercise, you have to click on wall test. Do you want to do in the class? Okay. From classroom, in the classroom, you will have the data name rice. Let's open it, rice. Open rice. Okay, open rice. And then do the equation. Okay, then you do log production. Yes, so constant log area log labor and log fertilizer. Okay, so you just do this one, the equation, right? And then you see with your eye that beta 2 hat, beta 3 hat, beta 4 hat, right? 0.36, 0.43, 0.02. Okay, you sum it. Professor, sum it is just 0. No, it's just one something, 1.01 something, Professor. So they would like to know whether beta 3 plus beta 2 plus beta 3 plus beta 4 equal 1 or not. This called constant return to scale. Okay, which is very popular topic in economics. Okay, so can I answer that? Oh, professor, I try calculation. It's not equal one. Can we do that? No. This is you see it by your eye. Because in the statistic, you have to test the hypothesis. Not you do not see anything by your eye. You have to do hypothesis. Okay, so you have to set H now O beta or equal to 1. Yes. Then to do that in the program, you click view, okay, coefficient and vault, vault, W-A-L-E, vault. Okay, and then you type beta 2 equal beta 3 equal, oh, not equal, plus, sorry, plus beta 3 plus beta 4 equal 1. Okay, then click OK. But your duty is to know how to read the result. Okay, if you know that if you set the equation like this, it means you use F test. It's a F test. So your duty here is to read the probability. Statistic. Okay, so you can see it whether it's greater than 0.05 or not. If it's greater than 0.05, it go to H now. Yes, H1. So what is HO? What is HO? HO they said beta 2 plus beta 3 plus beta 4 equal 1, right? Again, HO is yes, this is now hypothesis. We type it together. We said that all the beta plus equal 1. What does it mean? In economics term, what does it mean? Economics. Oh, this is the hint. What does it mean? What does it mean? What does it mean? Oh, I hint this a lot. What does it mean? No, no, what does it mean? Yes, it's constantly turned to scale. Constantly turned to scale. Tired, 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 really tired. Yes, because this what they would like to test whether is constantly turned to scale or not. Since okay, you sum the beta and it 1 point something, but you cannot believe in your eye. You have to do hypothesis testing. And after you do hypothesis testing, you found that okay, it's equal 1 and it constantly turns to scale. This is the answer. Okay. Okay, then they re-estimate the model by omit some variable. Discuss the effect of omitting variable. Okay, check the reset and pick up the omitted variable. Okay, so this exercise they try to drop some variable. For example, previously we have area labor fertilizer. We have only area and labor, right? We drop fertilizer out. Okay, this one we drop labor out, and we drop per here, so we drop area. And then you can see the coefficient. Okay, area 0.45 0.66. Labor 0.56 to be 0.57. Okay, so the coefficient okay, then dramatically change if we drop important variable. We call the situation that if we drop some important variable and the coefficient change dramatically, we call it omitted variable bias. Oops. Oh, it's back. Yes, because previously we can see that all variable significant at 1%, right? And if we drop some important variable, coefficient change a lot, change dramatically, change a lot, right? So the situation that coefficient change a lot, we call omitted variable bias. Variable bias. Bias. Yes. You okay? It's difficult, right? Difficult. Okay, just see one of them. Okay, so I then test for omitted variable. Okay, so this called omitted variable test. Okay, omitted variable test. Then I try to omit log fertilizer out. So H now here in omitted variable equation is no omitted versus omitted variable. And then for omitted variable test, you have to see F stat. Please answer me accordingly. H now or H1? Zero. H1. Good. H1. So it means you get omitted variable. Okay, so please practice to read probability. Okay, and follow my step, and you will pass my exam. Okay, so Shall we start the new chapter or review? Okay, let's do the new chapter. This is the final chapter of midterm test. So we call the indicator variable. Okay, so indicator variable is mean, yes, indicator variable. It mean, mhm. It mean previously you have the data with a number like size, age, they are all number, right? But how about if I say something about location? Location. For example, I would like to know that the house in urban and rural, what is the difference in price between house in urban and rural? Too difficult? Yes. Yes. High price. Yes, this is makes sense, right? Then I ask you again, how much the difference between rural and urban? No, you have because you learn with me. You have okay. I will use the model to predict it. The model will answer, right? The model will answer. Okay, but but this is like a characteristic. So how can we use this text in our model? So we use the technique called indicator variable. Okay, so indicator variables, some textbook using the word dummy variables. So this is the same thing. Okay, so this is the technique to account qualitative factors by assign the value of qualitative factors to be 1 and 0. For example, rural urban, you may say that urban equal 1, rural equals 0. Okay? So this technique we call indicator variables or dummy variables. So how do you come to the university? Do you use a subway? Do you use subway or do you use with transportation? Do you use diving? Diving as well? Do you use public transport, train, MRT? Yes, that's MRT, right? How about if your condominium is far from MRT? It's not convenient, right? Very close, right? So the price of those condominium must be higher. So how much? Mhm. Yes, if you go to rent the same size condominium but far from MRT, lower price, right? Yes. So I would like to ask you, so how much difference How much difference? Yeah, yes. You have to use the model. Yeah, good. Yes, good. Yes. Okay, so you have to use the technique of dummy variables. So the price of your house depends on the size, right? How many square feet, and then use the dummy variable. For example, if dummy variable equal to what is mean is close to MRT or BDS, but zero is not not close. Okay. Okay, then I give you some exercise to fill following dummy variables. I have several house for you. And I do for dummy variables here. So whether is it in town or not, if in town equal one, whether those house have a pool or not, whether that house close to the river or not, and is it in Bangkok or not. Okay, so first house, they have text like house in town, pool available in Bangkok. So house in town, so town equal one, pool. Yes, pool available, so pool, no two, so pool. Dummy available is one or zero or not. Pool is one. River, so it's yes, it's in town, right? So it is in Bangkok. Good. All house outside town. No pool. Close to river. And it's not in Bangkok. Yes, good. Yes. Next house in town. One. No pool. Close to river. And it's in Bangkok. Next is pool villa. So pool is one. Outside town. Close to sea. No, sea. And it's Pattaya. Zero. All right. So this is how we convert from text, right, to be number. We use the technique called dummy variables. Okay. So you set the number zero or one. It means yes or no. Mhm. Right. Okay. So the ways after you have dummy variables, so there are three style of dummy variable. First style we call intercept dummy variable. Okay, so price depends on the size and dummy variable. So imagine that this is MRT. Okay, so if dummy equal one is MRT. If dummy is not equal is not close to not close to MRT. Okay. Mhm. Yes, so intercept dummy means is a parallel shape. Yes. So let's imagine the house that not close to MRT, so dummy equal zero. So this one is zero, right? So it become square feet. So this is the normal equation, just normal equation. But when this house is close MRT, dummy equal one. So the intercept change from beta 1 to be beta 1 plus something. So if we plot at the chart, it means the starting point, right? The starting point of the house is different. It shift up. So why the price between house that close MRT and not close MRT are different? It means the initial price are different, right? Initial price, so it means the intercept is shift. Starting price, I may use to formal word. Starting price. They they shift completely. For example, if this parameter equal 8,000, for example, it means the house that close MRT have the price higher than not MRT by 8,000. Okay, so it cheap by 8,000. For example, so this is called an interaction variable. Okay, as it capture interaction effect of location and site on our price. Okay, then when you interpret that in the for the dummy variable, you have to interpret as if the house close to MRT is more expensive than not close to MRT by 8,000. Right? Make sense? Mhm. So that's why the two house, maybe if in your case it's two apartments, the same size, but just the location is different. The one that you can walk to MRT, but the one that very far from MRT, why the price is different. This one. However, the one technique, when you use dummy variables technique, please be careful. This one is called dummy variables trap. Okay, dummy variable trap. Okay, uh, for example, you have one dummy variable that this is MRT. Okay, but you also add other dummy variable. This is not MRT. If you do that, you will get dummy variables trap. Yes, trap. Because you have two dummy variable here. Okay, so first half very close to MRT. Second, not close. The third one, not close. Something like that. In this case, MRT plus not MRT away equal 1. We call, in the technical term, we call exact collinearity problem. You may learn it later, but the meaning is that if you do that by put two dummy variables at the same category, the least square estimator is not defined. This means you cannot find the answer. Yes, if you put too much dummy variables in the model, you have to delete one. Good. Yes. So they have a rule for using dummy variable. Okay, they have a rule. So if you have in category, use dummy only n minus 1. Okay, so we have only MRT or not MRT. We use only one dummy variable is enough. If not, your model will face dummy variable trap and cannot find the answer. Difficult. I will give you one more example, and this is very classic because a lot of my students did the mistake when they collect the data. Okay, so the very classic dummy variable trap is about the gender. So this researcher would like to know the wage. The wage of people depends on their education. The higher education, the higher wage. Makes sense. But they would like to know the difference between male and female wage. Then they know because they may learn with me. They use dummy variable male, female. Where male equal 1 is male, 0 is female, female 1 is female, 0 male. Then you collect the data male, female. The first one is Mr. something. Okay, Mr. male is 1. Second one is Miss something, female is 1. Yes, yes, of course, of course. Yes. Then you collect the data and then put both variables in the model. So male plus female always equal 1. This means this exact collinearity or dummy variable steps. Okay. Then you when you have only two categories, you use only one dummy. Yes, you use another noun. So you have in the category here, you have only male and female here. Then you have to minus one. So you have only one dummy variable. For example, you may use gender. Then gender one equal male, zero equal female. Or one is female, zero is male. And the answer is completely the same. Okay, answer will be the same. Mhm. Just change direction. Okay, so you can set either equal one. Answer still indifferent. And then how can we know the weight of each gender if we put only one dummy variable? I will show you. Okay, I will show you. So only one dummy variable we can know both gender weight. For example, first, if we set gender equal one is male and zero is female. So let's consider female case first. So female gender equals zero. So gender zero, right? So the weight become only depends on education like this. So it starts at beta one and the slope is beta two. So this is female. How about male? Male gender equal one. So the intercept shift from beta one to beta one plus beta t, beta one plus beta three, and this is the weight of male. So in this case, it means the initial or the starting salary of male is greater than female, right? Because it jump. So why male? Hmm? Why male have the weight higher than female? It not depends on their education. It depends on the starting salary. If we do in this case, okay, you may argue with me why male must greater than female. So it's not always greater than female. It depends on the direction of beta 3, right? If the beta 3 is negative, yes, if the beta 3 is negative, it means the starting point must be somewhere here, right? If the beta 1 plus beta 3, but if it's negative, male must be lower than female. So it depends on beta 3. Okay, so I think you need some rest. Let's break for a while. Maybe you come back at 25. Okay, to make it less confused, I maybe leave only the positive case here. Mhm. This is the one that our student undergrad the work claim that this subject is the most difficult because they didn't learn with me. Yeah. Okay, so before we break, I introduce you the intercept dummy variable. This means the parallel shift. How about if I would like to do another thing we call slope dummy variable? Okay, so instead of initial shift, we shift in the price per square feet, price per area, right? Square feet by per square feet are different. Okay, if you have the idea that the price per square feet must be different, you have to use slope dummy variable instead. Okay, so instead of leave dummy alone, you multiply the dummy multiplied by its slope. So it is called slope indicator variable. It allows a change in the slope of the relationship. Okay, for example, D equals 0 is mean not close MRT, where D is MRT. So if it's not close, so it's become the typical equation. So price depends on beta 1 plus beta 2 square feet. Then dummy equal 1, which means the square feet are here together, so we can sum the beta 2 plus this one is gamma. Okay, so the initial price is the starting price is the same, but why the price different from why the price is different between the one that close to MRT, the one that not close to MRT, because the price per square feet is not the same. Okay, clear? The starting price is the same, but they charge you per square feet higher. Depends on gamma here. Okay, and the last technique we call why not both? Why not both? So we call mixed dummy variable. We have both intercept one and the slope one. So it indicates that initial price is higher and the price per square feet is higher as well. So we have both intercept shift and slope shift. And let's see the example. You will understand more how to use dummy variable. So this data, they would like to know the university effect on house prices. So they would like to know whether the house that close to university have the higher price than the house that far from university. So they have the variable name U-tau. U-tau is mean if it's close to university, it's become 1. If not, it's become 0. They have other variables as well, square feet, the size, the age, the pool is mean they have pool or not, And F place, this is fireplace. And imagine this in USA, very cold. If the house have fireplace, the price will become higher. Mhm. 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 Utah, yes. Two, yes. Okay. You can do different question as you want. And so this is the example that they did. Okay. They did the equation like this. So they put all the dummy variable plus they multiply Utah with square feet as well. So they use both intercept and slope dummy variable. Okay, what does it mean? So it means if house in another area not close to university, Utah is zero, right? Utah is zero. This means the equation become price equal 24 plus flight plus 5 here plus 7.61 square feet, right? Minus h. Yes, yes. Okay. So you understand it clearly. But how about house that near university? Uh-huh. So this one is one, right? So price again equal exactly, exactly. Yes. So what does it mean? It means the mhm, university have ha- have has no this one first. Mm, mm-hmm. Square feet. Yes, 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 yes. And the less is the same. Okay, again, it's the same. Okay, so the point is here, the difference between price between the one that near university and not near university is this better, right? What does it mean? It means if the house near university, they have higher starting price, right? Higher starting price and even price per square feet is higher, right? They charge the price per square feet more expensive, then they set the starting price more expensive. This is what we found from the result. Okay, moreover, how to, okay, I will set the number first. 1, 2, 3, 4, 5, 6, 7. I think for some of them, you know how to interpret it code accordingly. But how about if I would like you to interpret beta 6 hat 2? So beta 6 hat is 4.37 with probability. Please answer. 0.033 is less than, not point 0.5, not point 1. Good. Indicate that. It, right? Okay. So some of my students undergrad level, when they face, oh, because professor teach us already. Linear is unit. No, I interpret it. If the pool increased by 1, no. Okay, I will write the wrong answer. If the pool increased by 1, no. It doesn't mean that those houses have two peoples. Yeah, yes. Yes, correctly. Yes, good. Not the pool increased by 1 is incorrect. So to interpret the dummy variable, you have to say that if the house have pool, yes. Yes, price increase. Oops. Yes, significant at 1% level. Okay, this is the real meaning. Do not say have one more pool. No. Have one more 5 days. No. You have to say have and don't have. Good. Okay, one more time. How about F less beta 7? Mm-hmm. Mm-hmm. It's 0.09, so it means 0.1. Good. Mm-hmm. 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 Good. At and 10% level. Good. Yes, this is the real meaning. Okay. Mm-hmm. Okay, so they have summarized in next slide. Okay, we therefore estimate that location, okay, the chain price per square foot, the house price, and yes, the pool increases the value of home by this amount. A fireplace increases the value of home by this amount. Okay, see more example, but to save the time, I will indicate only the first one. Okay, I will show you only the first one. So this is what happened in USA. So they try to estimate the wage depends on whether two dummy variable. So black equal 1 is mean you have the black skin, okay, and equal 0 if you are the white normal people in USA, okay. And we have variable female equal 1 if you are female, equal 0 if you are male. Okay, so two category, only one dummy variable. Okay, then they use interact. This is called interactive, interact variable here. So what does it mean? So from this equation, you can distinguish into four people types. Firstly, the easiest one. How about if you are white male? So white male, black is zero, female zero, here is zero. So the wage become beta one plus beta two education, and that's all, right? Because this zero is zero, 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 zero. Huh. Yes. So let's connect if you are white female. What happened to the equation? So female here is one, right? After zero zero. So the weight will shift to become beta one plus rho two, right? Plus beta two education. How about if you are a black male? Okay, female zero zero. So weight here beta 1 plus low 1 plus, and lastly, black female. Okay, so this term is it 1, so this exists. So which equal beta 1 plus low 1 plus low 2 plus gamma. Yes. Okay, so only use dummy variable you can estimate every type of salary. So it depends on the direction of three parameters, right? If they are negative, it means the wage discrimination, the wage of them become lower, right? If you are black, your wage become lower. If you are female, your wage become lower. Or even worse, if you both black and female, if this one have a negative, your wage even lower. Yes. Okay, so let's see the result. So they estimated. Mhm. First, if you are black, this is happened in USA, okay? Not in Thailand. It's USA. Let's blame them. Let's blame them. Okay, if you have black skin, negative, significantly. Female, negative, strongly significant. But female, luckily, is not significant, right? Mhm. So it means they have the wage discrimination, right? By they try to lower black wage, right? Black labor, and also they try to lower the wage of female labor. So this what happened in USA. Mm-hmm. 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 Actually, it's not significant, right? Not significant. So, or you may be black and you may be female. Okay, your salary is even lower. But this is like a more additional discrimination. This means if you both black and female, do they even lower the salary or not? So the result is not significant, so it's lucky here. If it's significant, it means it's even low. even low. Okay, so it's positive but not significant, so that's okay. But this one, if you are black, your weight is lower. If you are female, your weight is lower. Did you get it? Mhm. Okay, because it's significant and have the negative. So surely in USA, if you are black, if you are female, the salary is lower than white male. Mhm. Moreover, dummy variable can use for time series data as well. For example, you can use for seasonal. Typically, in the official data ละกัน official in Thailand we have three seasons in Thailand. Only one. Summer. Yes. But when I was child, they have the winter as well. Winter, summer, and raining. But like right now, winter is gone. It's like we have winter only 1 or 2 days per year. In December, you can wait for December. You may feel Chiang Mai, yes. Okay. So let's recall the memory. We have three categories here. How many dummies variable should we use? We should use n minus 1, right? So we can include only two variables in the model. Okay, so use only two dummy variable. Either is okay. The answer will be the same. You can use winter or summer, or winter and raining, or summer and raining. That's okay, but just not use all three. Uh-huh. And this one is very famous for macroeconomics. Variable you may use is for structural break. For example, you would like to know the effect of COVID-19. Okay, okay, you may set the COVID-19. Okay, so this is the year 2017, 2018, 2019, 2020, and today's. Okay, so before COVID-19, you set it equals 0, and then after COVID-19, you equal 1. Okay, so you can do the structural way. For example, you may forecast the sale, right? Sale depends on something here. Then this is COVID-19. Okay, sale increase, then the sale decrease. Okay, you can use structural break COVID-19 to represent this figure. So this is like an intercept dummy. However, you may use slope dummy as well by, okay, this is COVID-19, the cell increase, and then after COVID-19, the cell is not increased anymore. So you apply slope dummy. So we call the structural break. Okay, and then last but not least, if we face log linear model, okay, so you can uh, delete this one. Okay, it's too difficult. But if you face log linear model with dummy variable, you can interpret by using a rough calculation by multiplying by 100. Okay, so this will become the log linear interpretation. Okay, it means if you are female, the weight will decrease by 24.32%. Compare with male. Okay, or 24.32% differential between male and female wages. Okay, so let's do exercise together in the class because I do not want you to have more homework. Okay, so this means all homework that you have sent me already is already count. You get full already 10 points. Okay, so we don't have homework anymore. We will do it together in the class of our exercise and then we will finish the course, maybe the midterm. Okay, not the course. Okay, so let's see the first question. Um, okay, the first question. Let's skip the first question. Let's study after the second part. Okay, skip. Let's skip. Uh-huh. Let's study again at the second part. I think we have less time here. So let's go to 6.2, which is more important. Okay, so this is the question that they want to know about econometrics affect salary or not. So salary depends on the grade and whether they already learn econometrics or not. Okay, so using the data by metrics. Okay, let's do that. Metrics. Metrics. And then they would like you to do salary. Well, the color is so bad. Salary depends on constant, depends on GPA, and depends on metrics. Okay, so you can follow the step object, new object, EQ, right? Salary, C, GPA, metrics. Oh, salary, you have to write in full salary. And because the variable name here is salary, not SAL. Okay, you have to use salary, C, GPA, and matrix. And you can either use capital or small. The program is capable to do that. Do you get the result? Yes. Okay, we have like 30 minutes left, so let's interpret again. So after you see this equation, how should you see first? What should you see first? Of F. Is it okay? Okay, right? Because okay, good. How about yes, yes. How about R square? Mm-hmm. Mm-hmm. Good. Okay, then we move to T. Okay, so one, two, three. Let's interpret GPA first. So better to have. That's okay. Then okay. Yes, good. Okay, this means if CPA increase one unit, right? Because okay. Yes, good. Significant. Good. 1% level. Okay, this is a typical thing that you can do. But how about beta 3 hat? This is the dummy, dummy. If they learn econometrics equal 1, if they never learn econometrics equal 0. So how should we interpret? Okay, let's see the prop first. So prop is, let's see the probability. Mhm. Mm. Okay, you may read in the slide. So it say that if they took, they took econometrics, this subject, salary is increased 5,000, yeah, dollar. Yes, 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 yes. Yes. Okay, this is true. After you finish this class, your salary must increase by this amount. 5,000 per year. Yes, yes. I use the word from the slide that they say that matrix equal one if student took econometrics. So this means if you learn econometrics, your salary will become higher significantly at 1% level. So you have to go to tell your boss, you must increase our salary right now. Because this model said so. Uh-huh. Then they ask you, how would you modify the equation to see whether women had lower starting salaries than men? Mhm. Yes, they already have this variable already called female. So how should we do? Because they would like to do the starting salary. So we should use intercept dummy. Okay, so from this equation, okay, you click estimate, click on estimate here, and then add female. Okay, so salary CGPA matrix female. Okay, yeah. You get the same. Okay. Okay, you know how to interpret it accordingly. But however, how do you interpret beta for female? How do you interpret this? Ooh. Okay, you get this print out, and I will focus only the dummy variable that we add here. Okay, so beta hat for equal minus again. So what does it mean? Okay, crop. Yes, yes. It is insignificant. So let's try to write it in full sentence. What does it mean? This mean, okay, you can write in two ways. First, you can say that female mm, and has lower salary by $204 than men, right? Than men, than male, not is female, but not significant or okay, not significant, or you can write insignificant, that's okay. Moreover, you may write that gender, or the color is so bad. Let's change the color. This means gender has no effect on salary. Okay, you can write this one or can write this one. Depends on the style that you need. Uh-huh. Next question. How would you modify the equation to see if the value of econometrics was the same for men and women? So they would like to know that the metrics here different between male and female or not. Yes, we use female. What that is called? It's called slope dummy. Slope dummy. So instead of use female alone, you have to use female multiplied by matrix. Okay. So you click add estimate again, then add multiply matrix. Oops. Okay, so how was the result? Yes, okay, let's try to interpret this one again. So beta 4 half equal minus 12, but uh-huh, yes, 0.1 indicate that. Mhm. Yes, it's difficult to write down the yes, insignificant, but what is insignificant? Mm-hmm. Mm-hmm. Well, mm-hmm. 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 Yes, that's okay. That's okay. Uh-huh. So since this one you multiply with matrix, right? It means if you were female mm, have this the negative, right? Lower effect of econometrics, right? Metrics to salary than male because it's multiplied, so you have to write the multiply things by 12, but insignificant. Or alternatively, you can say that gender has no effect on not salary because it's multiplied by metric on oh, has no effect on the effect of metric, yes, metric on salaries. So this one is like a very complicated sentence. They must be, more formal sentence, but this is what I can do my best. So really complicated sentence I construct. I don't know how to make it more clearer, but yes, this is the real meaning. But the sentence may not be beautiful. Okay, let's move to the final uh, homework, not homework, maybe it's final exercise because we don't have homework yet. Just do it together in the class. Okay, we will do some of them here. Okay, so this is log linear. Yeah, log linear. So this is the data of sales, weekly sales of canned tuna, canned tuna by a supermarket chain in US. And then they would like to estimate that whether the number of sales depends on the price and competitor price. Okay, because we number one can tuna depends on the price of number one can tuna. Yes, of course, this is like a law of demand. And then depends on the competitor price as well. Okay, so better to a better P, a better for is like the competitor price . Okay, so this is its own price. So the sale depends on our price and competitor price. Uh-huh. And then the dummy that they make, first they do the advertisement, uh-huh, in the store display. Okay, this is the dummy for store display. And then display advertisement, this one they use store display. Plus they advertise on the newspaper as well. Okay, so both are dummy. So let's open the data of tuna, tuna work file and then do it, and we will interpret the model together. Okay, tuna, 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 tuna. Okay, and the equation that you have to do is cell 1 C APR1 APR2 APR3 and then display and display advertisement. Okay, object, new object, EQ01, sale depends on concept, depends on the price. Display and display advertisement. Okay, click OK. Then follow our step. This overall model is okay because how do you know that? Yes. Ah. Mhm. Okay. Overall is okay. Mhm. 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 Good. Yes, very good. So how about each? Oh, sorry. Please add because this one is the log linear exercise, so you have to add log salary. Okay. Sorry, my bad. Okay, our log salary. Mm-hmm. Okay, become better. Okay, do you get the same result? Okay, so again, of f is the same, but the r squared become higher. Yeah, but how about interpret? 1, 2, 3, 4, 5. So better to add Uh-huh. Good. What does it mean? Log linear. So you have to open log linear to answer log linear. I have if I have price, right? Price increase one. Uh-huh. So do they have the unit for us? Yes. If price increase $1, uh-huh. Sale decrease. Yes. Significant. Yes, at 1%. Yeah. Full mark. Okay. X L constant. Okay. So this is make sense or not? Make sense? Make sense because it's a law of demand. You higher your price, your sale will decrease. Mm-hmm. How about beta 3? 4. Okay, one, five. That's fair enough. Okay. Hey, let's see. Mm-hmm. Yes. 0.05. Uh-huh. Be careful, be careful. Uh-huh. Yeah, this is like a competitor price, your competitor. Uh-huh. Yes, percent. Good. Significant at 5. Yes, and the Excel constant. Make sense? Because why it make sense? Why is make sense for you? Why? Why? The reason. Competitor. Mhm. Yes, that's correct. Because your competitor designed to increase their price, the consumer will come to buy your brand instead because yes, they will shift to consume your goods instead. Yes, so this one positive is makes sense. Whether for 1.4n. So probability 5. Yes. Mhm. Yes. Yes. Yeah. Yes. Good. Good. This makes sense or not? Makes sense. The reason is the same as previous plan. How about beta 1, 2, 3? Oh, I I write it incorrectly. Right? My bad. It's 2, 3, 4, 5, 6. So next is beta 0.42. This is the dummy variable, okay? Dummy variable, and this yes. So if so, you have to come back to read the equation. So this is the if store display. Okay, if store display the product, uh, if store display the product, mhm, the sale increase multiply by 100 again, 42%. Good. And is significant at 1%. Good. And lastly, because I use too much space here, we have to write down here, okay? 1.43. Good. Newspaper, this one is newspaper. Mr. Okay, I will read for you. Store display and newspaper is. Okay, if store display plus newspaper uh, advertisement sale increase percent. Yes, and the AQ constant. Yes, that's it. That's it. Okay, keep your performance like this, and you will pass my exam. So you have to know how to read the model correctly. Okay, so there are only four types of model. Okay, you have to practice them all: linear, lock, lock. Mhm. Okay, we have several minutes. So how about we do some exercise here? I would like to test whether the advertisement has no effect at all. Okay, so uh, on the other hand, how can I say, or I would like to test whether beta 5 equal beta 6 equals 0 or not. It means you do not need to advertisement because it's no effect on the cell. What should I do? What should I do? I would like to test whether hypothesis testing. Yes. So you have to use wall test. Okay, please remember this word wall test. Mhm. Okay, so you click on your model to be viewed. Coefficient diagnostic wall test. Wall test. Do you find it? Then type C5 equals C6 equals 0. Click OK. Okay. Then how do you read this printout? Okay, so in the exam, I may give you the printout of wall test, so you have to jump to see the null hypothesis. This is H null, so this is beta 5 equal beta 6 equals 0, right? Then you can see probability. If it's greater than 0.05, we go to HO. If it's less than 0.05, we go to H1. Sorry. Sorry. Zero. It's less than of H. Less than. We should H1, which mean, yes, we reject. What does it mean? This mean, how about to, this is correct or not correct? So you have to say, is not true. Uh-huh. And now it's not true. So you can write beta 5 equal to beta 6 equal to 0 is not true. Which means advertisement affect sales. Sales only, not the price, sales. Mhm. And that's all my lesson today. Okay, hopefully you enjoy learning econometrics because the second part it will become more difficult than this. So the key point is you enjoy learning it. Yeah, yes. If you enjoy learning anything, nothing is difficult for you. Okay. You have a sweet part. So thank you for hard working, and we see you again on the next 2 weeks in the exam room. Yeah. Okay, thank you for today.